To fully understand this, it's going to be valuable for us to understand what this is. So this is a difference of squares. So x squared minus 1, x squared minus 4, minus 9. Hopefully you see a pattern here, 16, 25. All of these break into x plus 1 and x minus 1. It's a shortcut you learned back in 8th and 9th grade. X plus 3, x minus 3. It doesn't matter if the positive or the negative goes first. So when you see this, x squared minus 25, I can rewrite that as x plus 5 and x minus 5. There's more than one way to do this problem, but I do believe there is an easier way. So we have three different groups here, and I want the denominator to be x plus 5 and x minus 5. So what is this denominator missing so that would look like x plus 5 and x minus 5? What's it missing? It's missing x minus 5. Whatever we attach to the bottom, we must also attach to the top. We have to keep the same value intact. So I attached an x minus 5 and x minus 5, bottom and top. Now what about the second group? It has an x minus 5, but it's missing a, so we attach an x plus 5, we attach an x plus 5. Now why do we not have to do anything to the last group? It already has it. So this is the cool part. When we're working with rational equations, there's an equal sign. Once the denominators are all the same, we wipe out the denominator and we only have to solve the numerator. So I have 4 times x minus 5 minus 2x times x plus 5 equals negative 10x minus 50. So the first thing I'm going to do is I'm going to distribute. Okay, so I'm going to distribute the 4 to get 4x minus 20. Distribute the negative 2x to get negative 2x squared minus 10x. And then I think it's to our advantage to always have a leading coefficient that's positive. So here's the leading coefficient. It's the only one with an x squared. It's on the left side, but it's negative. So I'm going to move everything over to the right. This moves over and it becomes a positive 10x. This moves over, it becomes a positive 2x squared. This moves over, it becomes a positive 20. This moves over, it becomes a negative 4x. So everything now on the left-hand side has moved to the right-hand side. And I'm just going to write them out, and then I'll combine like terms. Now, you're welcome to combine like terms in your mind. I'm just doing this so everybody can see before I get started where everything comes from. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I have all 6 terms there. Does anybody have a question where I got those from? Yours may be in a different order. Okay, we have a 2x squared. Okay, we have a 2x squared. Let's look at all the x's. Well, negative 10x and positive 10x cancel. There's a negative 4x. Negative 50 and 20 is a negative 30. We could factor from here. We could use the quadratic formula, but all of these are even. Let's factor out a 2 to make our lives easy. Dividing by 2, 0 divided by 2 is 0. And now, this is much, much easier. So I can factor here as a method of solving what multiplies to give us negative 15 and combines to give us negative 2. Anybody know the combination? 5 and 3, a negative 5 and a positive 3. X minus 5, x plus 3. Okay, I'm going to add 5 to both sides. X equals 5. I'm going to subtract 3 to both sides. X equals negative 3. I've got my 2 answers. But why do I still need to be nervous that these answers may not work? Does anybody know? Yeah, we have to go back up to this original problem. I'm going to flip so you can see the screen. This is the original problem. And so I'm looking in the denominators. And I'm asking myself, so I have answers of 5 and negative 3. If I plug in a 5, anytime there's a variable in the denominator, if I plug in 5, I get 10. That's good. But if I plug in 5 to the second term, what do I get in the denominator if I plug in 5? If I substitute 5 in for this x, I end up with 0. If I plug in 5 to this original problem, 5 minus 5 is 0. You cannot have that. So I come up down here, I cross it out. This is an extraneous solution. That means I did all of the algebra right. Okay, then we're going to check to negative 3. So if I plug in negative 3, it does not equal 0. If I plug in negative 3, it does not equal 0. I'm only worried about the denominator. If I plug in 3, it does not equal 0. We have one solution of negative 3.